A lot of text to video models have recently come out, but not only that, a lot of other stuff has happened too, such as multiplayer Stable Diffusion, and OpenAI is looking for even more money from Microsoft. Stay tuned, this is ML News. Hello everyone, as you can see, I'm not in my usual setting. I'm actually currently in Poland. It is the last day of the Machine Learning in Poland conference. This conference is absolutely glorious, absolutely fantastic. It was really cool being here. It is over now. I'm going home, but next year, please be here. Or if you're a company that's looking to get rid of some money and sponsor an awesome conference, the mlnews conference has been organized at least as well as any of the NeurIPSs or ICMLs that I've ever been to. And it is very likely that this conference is going to grow and become more notorious in the next few years. There was a great lineup of keynote speakers, tutorials, and other content. And I even had the pleasure of joining into a bit of a concert at one of the poster sessions, which was certainly a unique experience. So thanks again to the mlnpl organizers. See you there next year. All right. So Stable Diffusion is going multiplayer. This is a Huggingface space. It's essentially a giant canvas, and you can just come in here and you drag this square somewhere and you give some kind of a description, and it will just kind of fit in what you're doing. All of this is collectively drawn by people, and I'm always afraid because I don't want to destroy something, right? Because all of this is just very, very cool what people come up with. Just another example of something that I would have never thought of, but because stuff is open and released, this is, this can be built. So absolutely cool. Give it a try, and maybe this inspires you to build something that is even cooler than this. I don't know what it's going to be, but I'm sure one of you has a great idea right now. Another Huggingface news, they introduce DOI, Digital Object Identifiers for datasets and models. DOIs are sort of a standard way in scientific literature of addressing things like addressing papers, addressing artifacts, and now Huggingface is introducing these things for their models and datasets on the hub. So on the hub, you're going to see this little box with which you can generate, essentially it's a UUID for a model or a dataset that is never going to change in the future. Now you can outdate it, so you can say, well, this one is deprecated, I have a new version of this model, but it is a unique identifier to that model that you have. And this is really good if you want to put it inside a paper so as to make it reproducible. And given that it is a standard, it just incorporates with the whole rest of the scientific ecosystem. So definitely a big plus for anyone who does work in research. The Wall Street Journal writes, Microsoft in advanced talks to increase investment in OpenAI. This article, essentially, there isn't much detail, but OpenAI is apparently asking for more money, more investment. Microsoft has previously invested about $1 billion into Microsoft, and on top of that, probably really preferential access to Azure in exchange that OpenAI will provide preferential access to Microsoft for its product. It's funny because here it says, last week Microsoft announced it was integrating DALL-E 2 with various products, including Microsoft Design, a new graphic design app, which is cool, and the image creator for search app Bing. Like, really? Is that their big plan? Is that the $1 billion investment to get Bing off the ground finally? I'm not sure. Now, keep in mind that just because OpenAI goes and asks for more money, that doesn't mean that they're bankrupt soon. It could also mean that they're planning for an even bigger push. Startups, and I don't know if OpenAI can still be considered a startup, but startups often, they do take on more money whenever they want to start scaling even more. Now, how much OpenAI wants to scale even more, I don't know. It could also be that they're just out of money and need more. The stack is a dataset. It's by the Big Code project, and it's 3 terabyte of permissively licensed source code. So this dataset is fully open. You can download it if you want to train anything like a Codex model or something similar. The dataset pays specific attention to the licensing of the code that is included in the dataset. The code is MIT licensed, Apache licensed, BSD3 licensed, essentially license such that you can do whatever you want with it. Now, that doesn't get you out of the weeds legally of doing anything and everything, because you still have to, do things like provide a copyright notice if you copy one of these codes verbatim. But the stack not only pays attention to this when they collect this initially, but also, as you can see on the Huggingface entry in the Huggingface hub, there are terms of use for the stack. And one of the terms of use of the stack is that you must always update your own version of the stack to the most recent usable version. And this is because they have essentially a form where you as a source code author can go and request removal of your source code from the stack. So even if you license this under MIT license, they don't want anyone's code who doesn't want to be part of the stack. So you can go and request that your code be removed from the stack. They will then do that, update the dataset, and by agreeing to these terms, if you download the dataset, you essentially agree to always download the newest version and use the newest version of the dataset, such as to propagate that removal of that code. Now, as I understand it, I'm not a lawyer, this is not legal advice, but as I understand it, you are entering into a binding agreement by clicking this checkbox and clicking this button. So, think about whether you want that or not, but it is good that another option is out there next to just scraping GitHub, I guess. Google releases Vizier open source. Vizier is a black box optimizer that works at scale. So many different experiments that need to be hyperparameter optimized. Vizier essentially decides which hyperparameter to try next. So you can run this as a service if you have a lot of parallel workers and you want to run hyperparameter optimizations. They have APIs for users, and the user here is essentially someone who wants to do hyperparameter optimization. They have APIs for developers, which means that you can put in new optimization algorithms. So if you're a developer of a black box optimization algorithm, you can integrate that with Vizier, and they have a benchmarking API. So apparently this thing has been running inside of Google for a while, and now they finally decided to release it open source. So it's certainly tried and tested. All right, now we get into the video models. There have been a few video models. Now they have been released a while back, but I'll just summarize them briefly here. Imagine Video is a text to video model. You can see a bunch of samples right here, and they look really cool. So this is a video diffusion model, but as far as I understand it, is kind of a combination of fully convolutional networks and super resolution networks in order to get this effect. They describe this further in a few diagrams on their website, saying Imagine Video uses video UNet architecture to capture spatial fidelity and temporal dynamics. Temporal self-attention is used in the base video diffusion model, while temporal convolutions are used in the temporal and spatial super resolution models. There is a paper to go along with it if you are interested. Now, also from Google Research is Fenaki. I'm not exactly sure how to pronounce that, but it is a different text to video model that can produce up to minutes long videos with changing text. So here you can see a prompt that constantly changes, and as it does, the video changes as well. So rather than being a diffusion model, this model compresses video to a tokenized representation and then essentially uses a causal autoregressive language model to continue that tokenized representation. With that, they're able to essentially produce unbounded video, as the beginning of the video simply drops out of the context. But as long as you feed into the side input more and more text that you want to be produced, you can see that the video keeps changing, keeps adapting, and keeps being faithful to the currently in focus part of the prompt. What's interesting is that the training data seems to be mostly text to image, with just a few text to video pairs inside of the training data. Now, we're not done with the text to video models yet. Meta AI actually released Make a Video, yet another text to video model. And this one is also a bit special because it essentially only produces a single image from text. So this is a essentially text to image model and then an unsupervised video generator from that image. So the text to image model is essentially, as we know, text to image models, but then the video model is unsupervised. It simply learns from unsupervised video data how video video behaves, and is then able to take a single picture, like a single frame of that video, and make the entire video out of it. The results look really cool. And what I think is cool between all of these works is that they all have a different approach for the same problem. All the results they produce are very cool, and it's going to be interesting to see how this text to video problem will ultimately be like canonically solved, let's say. I don't know, but I'm keeping my eyes open. Now, slightly different, but not entirely different, is Dream Fusion. This isn't text to video, this is text to 3D. Now, if you think that, is relatively straightforward, then no, none of these things actually involve 3D training data, at least as far as I can understand it. Rather, what they do is they consider the entire scene essentially like a nerf. So what they do is they start with a random 3D scene. So you pick your 3D scene, you fill a bunch of voxels and don't fill the other voxels. And then you optimize that 3D scene to satisfy text to image models that essentially act as photographs of that scene. So it is a lot like nerf, except that you don't have pictures, but you like optimize for a text to image model rather than optimizing for an actual image. And that is a really cool idea, and it actually seems to work pretty great. Now, there's other work still improving text to image diffusion models themselves. ERNIE VILG 2.0 is one of them. This is an iteration of the previous model, and it is using mixture of denoising experts. I don't want to go too much into this, but you can definitely see right here that the results are breathtaking and very good with a great resolution. Now, there is a demo on the Huggingface hub, but as far as I understand, this model isn't released. So the demo and the code that they put on GitHub, they simply calls some API where the model is actually stored. This is a neat tool not directly related to machine learning, but if you've ever wondered what like the difference between a bfloat16 and an fp16 is, I never knew, but Charlie Blake has a very cool tool on a blog that essentially shows you the different trade-offs you can make when you choose a number format. So it shows you for the different numbers what kind of ranges you can represent with them, where they're good at, where they're not good at. So you can see here clearly the difference between a bfloat16 and an fp16. One can represent a lot of numbers, and the other one can represent just very small range of numbers, but to more precision. Gridly.js is a tool that allows you to interact with grid world reinforcement learning environments. So there are a number of cool features right here. You can edit levels directly. You can also try out the levels. You can debug your policies. You can record trajectories. So right now I don't have a trajectory, but what I can do is I can click record right here, and I can move this thing around here, going to the lava, and then I die. And you can see the steps I've taken right here. So you can use this to do various kinds of things, debugging, investigating, and so on. If you are into reinforcement learning and you work with Grid World, then by all means check this out. Meta announces their new box, I guess. This is the box. This is an architecture for deep learning, the Grand Teton. Essentially, they release the architecture open source. So their engineers have sat down and thought long and hard about what it takes for a great machine learning system, like their bit more older DGX boxes, and they essentially tell you, look, we believe that this combination of hardware, this processors, these GPUs connected like this with these power supplies will be a very great base for doing research. Yeah, they're releasing these specs essentially for you to just buy or assemble, I guess, whatever you want to do with it. But I can tell you it is relatively hard to decide exactly on every component of the hardware, and it's really great that people who are very competent in this actually think about it and give their suggestions. So if you have a lab or a company and you really want to buy your own hardware, maybe this is a good option for you. Huggingface diffusers from version 0.5.1 on forward supports diffusers in JAX. If you like JAX, if you like Stable Diffusion, go for it. Muse is an open source Stable Diffusion production server. Well, it is not as much a server as it is sort of like a tutorial on how to bring up a server. This is based on the Lightning Apps framework, which is open source, and it's kind of an easy way to bring together all the components you need to deploy machine learning things. And this repository is essentially a specification on how to pull up a Stable Diffusion server. So if you want to deploy Stable Diffusion yourself, this is probably the fastest and simplest way to do so. TRLX by Karpathy is a library that allows you to do reinforcement learning for text models. So you can see right here, you can give either some sort of a reward function, or you can give a dataset that assigns values to expert demonstrations, and you can train a language model to incorporate that. This is a relatively new domain to do reinforcement learning on text models, but it is cool to have another library to tackle the problem. RL Baselines 3 Zoo is a training framework for Stable Baselines 3 reinforcement learning agents. Stable Baselines is a library that tries to give reference implementations of reinforcement learning algorithms because they're very tricky and they're very hard to get right. So these are good, solid, and performant reference implementations. Stable Baselines 3 is the third iteration of it, and this repository right here, the zoo, contains a number of surrounding things like scripts that make it very easy to interact with it, but also prepared agents and prepared hyperparameter settings that work well in different standard environments. JAX-Sec is a library that allows you to train very large language models in JAX. So the cool thing is that with this library, you essentially get things like data parallelism or model parallelism for free. You can just specify them and you can trade them off however you want. This is due to the power and simplicity of JAX. Albuminations, I hope I'm pronouncing that correctly, 1.3 is out, and it introduces a bunch of new image augmentations. This is a library for image augmentations, so it's good that they introduce new augmentations. That fits very well to the augmentations they already have. There's also a bunch of bug fixes and more. If you're looking for image augmentations in Python, this might be a good library. This is a really cool thing you can do with diffusion models. These people have trained diffusion models of brain images and were able to create new synthetic brain images with a degree of controllability. Now, there is a paper on arXiv if you are interested. You can also download the dataset of 100,000 synthetic brain images. CodeGeeks is a multilingual code generation model. So this is, as it says, it's essentially something similar like Codex, but it is released. You can actually go and you can download the model and use it yourself. MetaAI releases AI Template, which is an inference engine. So the goal here is to make inference faster. They get a lot of speed ups over just running standard inference in something like PyTorch. So this does two things. First of all, it optimizes your computation graph. If your computation graph contains a lot of like little operations that could be fused together into something that's really optimal for a given hardware, or just that can be expressed in a smarter way, then a graph optimizer can do that. And in a second step, there is a compiler to compile all of this to highly performant C++ code that runs on backend hardwares such as a GPU that uses CUDA or even an AMD GPU. So if fast inference is a concern to you, this is definitely a thing to check out. Nerf Studio describes itself as a collaboration-friendly studio for nerfs, but it is more like a collection, an entire collection of software to handle nerfs, anything from training, validating, or even experiencing yourself. You can see they have a viewer that allows you to just explore the nerfs that you do and make little videos from it, but really it covers everything to do with nerfs. Now, speaking of nerf, NerfAC is a PyTorch nerf acceleration toolbox. This gets significant speed ups over simply using nerf code that's out there. For example, a vanilla nerf model with 8-layer multi-layer perceptrons can be trained to better quality in 1 hour rather than 1 to 2 days, as in the paper. DStack, the logo doesn't exactly work on dark background, but DStack is a library that wants to standardize your ML workflows that you run in the cloud. This is essentially you check your workflows into GitHub, and DStack helps you to run them uniformly anywhere. So in a workflow, you can specify things like your workflow name, obviously, but then it starts. You can say, okay, my provider is bash, so this is essentially a bash script. Now, what are the commands? I want to pip install some stuff. I want to run this training script right here, but it also has things like artifacts, and you can also specify things like I want to load data from this S3 bucket over there. I want to run on this cloud over there. So all of this is quite geared towards machine learning. It's certainly not the first workflow engine or the first iteration from, hey, let's check our things into source code, but it is very targeted at running ML workflows in the cloud. Several people have figured out massive speedups in the OpenAI Whisper model. For example, this person here has figured out a 3x speedup on CPU inference, but refers to a GitHub thread where someone else has found an even bigger 3.25x speedup. Again, it's very cool to see what people do when you just give them the model. And lastly, I want to point to a couple of databases for stuff, mainly around Stable Diffusion. So Diffusion DB is on the Huggingface hub. It's a dataset of prompts that have been entered by real users into Stable Diffusion and the corresponding images that they got out. Public prompts, that's publicprompts.art in your browser, is a database of free prompts and free models. These models are mostly trained using Dream Booth, but if you're looking for inspiration for prompts and what they turn out, then this is maybe a good place to go. Likewise, visualize.ai is a website that goes a little bit more businessy, so it lets you create some free stuff from like Stable Diffusion, but then it also acts like as a bit of a marketplace for these things, such that you could also buy them or sell them. It's cool to see that different business models are trying to spring up around this ecosystem. Ultimately, someone will figure out how to really make money off of this stuff. But, you know, it's good to be part of the time when people are just trying stuff and seeing what happens with not only on the research side, but also on the business side. And lastly, Big Science has released Prompt Source, which is an IDE for natural language prompts. So this is a way to give people a bit more help and a bit more standardization when they use prompts to achieve certain goals. For example, when they use prompts to tackle some of the NLP challenges that are now more and more phrased simply as prompts into these large language models rather than as data that goes into a specially trained model for that task. So if you find yourself in this situation or a similar one, then Prompt Source may be for you. And lastly, this is a database of all Lex Fridman podcasts transcribed. This is the website of Karpathy, and he used a simple combination of a download script from YouTube combined with OpenAI's Whisper to transcribe all of Lex Fridman's podcast episodes. You can go to any one of them, you can click, and they are here with time annotations and all. It's a very simple but very cool project. Thank you, Andre, and I thank all of you for listening. I'll be home again next week. Until then, stay hydrated. Bye-bye.